Hello students, this video is in continuation of our series on theory of polynomial equations. So today we'll be discussing the topic of the nature of roots of a quadratic equation with respect to a real number. It's a fairly easy concept. I'll again try to incorporate as much graphically. I can explain you the topic as much as possible. So basically we again go to the same example or the same structure that we followed in our earlier videos. We'll take a quadratic equation of the format ax square plus bx plus c equal to 0, where a is not equal to 0 and b and c belong to some real number set. And also we'll take that alpha beta are two roots of the quadratic equation, and also we'll assume that alpha is less than beta. So these are the conditions that we'll assume. Now the first thing that we'll try to incorporate is what happens and we'll take that, suppose k, which belongs to real number. We'll consider the real number that we are talking about with respect to one real number. This real number is basically denoted by k. Okay, so this is the thing that we'll be taking. Now what happens when k is less than both alpha and beta? So this will be the first case that we'll be discussing. So now if we try to draw the curve, and suppose we'll take the example that a is greater than 0, and since alpha beta roots of that basically means that discriminant is greater than 0, and also alpha is not equal to b, so discriminant is not equal to 0 but discriminant is greater than 0, discriminant is positive. Okay, so if alpha is greater than 0, that means the curve will look somewhat like this. So that implies that this point is alpha and this point is beta. So alpha and beta are the roots, and it has been said that k is less than both alpha and beta. So suppose k be somewhere around here. Okay, so if we extrapolate, if we draw a vertical line from k upwards, then this vertical line will intersect at some point where this will be nothing but fk. If we take fx is equal to ax square plus bx plus c, then if we put fk, then fk will basically mean ak square plus bk plus c, which is nothing but this intersection point. So this is our concept over here. So as you can see, one more thing that I want to mention over here is that alpha and beta. So what will be the midpoint of alpha beta? So the midpoint of alpha beta, basically we know that midpoint of alpha and beta will be basically alpha plus beta by 2. And what is the alpha plus beta is basically the sum of the roots, and alpha and beta are the sum of the roots of ax square plus bx plus c. So alpha plus beta will be basically b by a, or rather minus b by a by 2, and this will ultimately give us minus b by twice a. So the midpoint, this midpoint where we are getting the minimum point, this is basically x is equal to minus b by twice a. So this is the graph that we are looking forward to. So as you can see over here, first thing first, we can see that k is less than minus b by a. So the first condition that we'll be getting is that k is less than minus b by twice a. This is the first condition. And the second condition that we'll be getting is that fk is positive. We are saying that fk is positive. So second condition that we'll be getting is that f of k is positive. So this is the condition. And f of k is positive, and also a is positive. Also a is greater than 0. So that means that a into fk will also be greater than 0. So basically we can take this point off, and ultimately the two conditions that we'll get is that we can write it down as, the first condition that we'll get is that a into f of k will be greater than 0, and the second condition that we'll get is that k is less than minus b by twice a. So these are the two conditions. And now what happens when a is less than 0? So if a is less than 0, it basically means, and also we are considering that k is less than both alpha and beta. So we did the graph for all a greater than 0, now we'll do for a less than 0. So if a is less than 0, that means the curve will look somewhat like this. So that means that this is the point alpha and this will be the point beta, and we take the k point over here. This is the k point. So as you can see over here, if we draw a vertical line from k downwards, so this vertical line intersects ax square plus bx plus c at this point, which is nothing but fk. Okay, and this midpoint is basically x is equal to minus b by twice a. So again, the conditions that you will get over here is that fk is less than 0, and also we have been given that a is less than 0. So fk is also negative, a is also negative. So if we find out the value of a fk, so this will basically negative into negative, which will be positive and greater than 0. So again, this condition is satisfied, and also you will see that k is less than minus b by twice a, which is again this very condition. So as you can see, it is immaterial. So it does not matter what is the value of a, whether a is greater than 0 or a is less than 0, it does not matter. If k is less than both the roots alpha and beta, then this condition will be satisfied nevertheless. So that is what we are looking forward to. So basically we can rub out the entire part. So we can rub out this entire part and just draw the curve in this format, that if this is alpha and this is beta, and we have a real number k which is less than both alpha and beta, and alpha beta are the roots, in that case we get this condition. Okay, so if k is less than both alpha and beta, this is the condition that is to be applied. I hope this is very much clear. We'll now move forward to the next topic, the next condition. So these are the conditions that we can get. So since we're done with this condition, and there's a lack of space over here, so let me draw it out and then we'll proceed to the next condition. Okay, so we're good to go. So the next condition that we'll try to think about is that what happens when k is greater than both alpha and beta. So what happens in this case? Let me try to draw the graph again. So we'll again take the example that if a is greater than 0. So a is greater than 0, so that means that if this is the x-axis, and since a is greater than 0, so basically this is the curve, and we'll have this is as alpha and this as beta, and we have k which is greater than both alpha and beta, so k will be somewhere around here. Okay, so now, and this point where the quadratic expression has the least value, basically this point is the point where x is equal to minus b by twice a. So this is the point. Okay, and now what we'll try to do is that we'll draw another vertical from k towards the quadratic expression. So this will look somewhat like this, and the point at which it will intersect, that straight line with vertical will intersect the quadratic equation in the graph, will be basically the point fk. Okay, I have already mentioned about fk in previous in the previous condition that we took. So what are the conditions that are coming out over here? So as you can see here, first condition is that fk is greater than 0. Okay, now a is also greater than 0 and fk is also greater than 0. So means this a is also positive, fk is also positive. So if we find out the value of a into fk, so positive into positive, this value will also be greater than 0. This is one condition. And the second condition, we'll see that k is greater than minus b by twice a. that k is greater than minus b by twice a. So basically the conditions that we finally end up with is, let me write it down over here, is that a into f of k is greater than 0 and k is greater than minus b by twice a. Okay, so this is the condition that we are finally ending up with. Similarly, we'll try to draw the graph for a is less than 0. Now if a is less than 0, so if this is the x-axis and we have the curve somewhat like this, so this will be alpha and this will be beta, and we have k somewhere around here, since k is greater than both alpha and beta. Now similarly, if we try to draw the vertical from k downwards, so this will be the point at which that vertical line will intersect the quadratic the graph. So this point is basically fk, not this point, rather this distance is basically fk. Okay, if I have mentioned it as the point in the earlier videos, it's not a point, but basically this intercept is basically fk. Okay, so now as you can see over here fk is below the x-axis, so this is negative. Now a is less than 0 in this case, so a is also negative, fk is also negative. So that means that if we find out the value of afk, so negative into negative, this will be positive. And also another condition that we'll find out is that if this is the point x equal to minus b by twice a, as we have already found previously, so here we'll get that k is greater than minus b by twice a. So as you can see, this condition is there and this condition is also there. So it does not matter what is the value of a, it does not matter what is the range of a, whether a is greater than 0 or a is less than 0. Irrespective of that, if there is a real number k which is greater than both the roots alpha and beta, in that case this condition is satisfied. So basically this is the condition that we are, this will basically be the conclusion that we'll draw if k is greater than both alpha and beta, and this is the graphical way by which it came down to. So basically the graph that we'll always try to assume is that if this is alpha and this is beta, and we have a point, suppose k over here, which is greater than both alpha and alpha and beta are the roots, then this leads to this condition. So I hope I'm clear, very much clear with this part. So there is another condition which we'll try to discuss, is that what happens when k is in the middle of the roots alpha and beta. So let me rub it out again and we'll try to think about that, discuss that condition. Okay, so we're good to go now. So the third condition that we'll try to discuss or think about is basically is that k lies between alpha and beta. So this is the condition that we'll be trying to understand. So similarly, again we'll consider that a is greater than 0. So if this is the x-axis, this will be the curve, this will be alpha, this will be beta, and suppose k is somewhere around here, k. Okay, so as you can see over here, if we draw a vertical line from k downwards, so this intercept will be basically fk. Okay, so as you can see over here fk is negative and a is positive, so a into fk is less than 0. Okay, and similarly, but the thing that we cannot find out is whether k is to the, since this point is the point where x is equal to minus b by twice a. Now in this diagram I have taken that k is to the right of minus b by twice a, but if we even take k over here, in that case also fk is negative. So we cannot say for certain whether k is on the right or on the left of x equal to minus b by twice a. So the earlier conditions that we took, where we mentioned that k can be greater than minus b by twice a or less than minus b by twice a, that condition is not applicable over here. The only condition that we have found out is that A into Fk is less than 0. So this is the condition. The next, similarly, we'll try to draw for A less than 0. So if A is less than 0, that means that if this is the x-axis, so we'll have a curve of this format where this will be alpha and this will be beta, and suppose k, we take this k point over here. So now if we draw a vertical from k upwards, so this intercept is basically Fk, this distance. So as you can see over here, here Fk is positive and A is negative. So if you multiply A into Fk, so A into Fk will be basically negative into positive, so this will be negative, which is less than 0. Similarly, we also cannot define the position of k, whether it will be on the right or on the left of x equal to minus b by twice a. So that condition is also not valid over here. The only condition that we get is that if k lies between alpha and beta, irrespective of the value of A, we get that A into Fk is less than 0. So that means that if this is the x number line, x-axis, and this is the roots alpha and beta, and we have a point k in the middle, in that case A into Fk will be less than 0, and this is the condition that we get. So as you have seen over here, we have discussed the nature of roots of a quadratic equation with respect to only one real number. In our next video, we'll try to discuss the nature of roots of a quadratic expression with respect to two real numbers, where we'll take k1 and k2, which are two real numbers. So you should watch that video as well, so that you get a deeper understanding over how this thing can be extrapolated over a two real number system. So thank you very much for watching this video, and in case you have any doubts or complications regarding this understanding this topic, then you can comment in the comment section below and we'll try to get back to you. Thank you very much.